July 18th, 1918. 4:35 a.m. The Retz Forest, north of Soissons, France. In the pre-dawn darkness, French infantry captain Pierre Duffieux crouched in a muddy trench, watching something that would have seemed impossible just months earlier. Through the ground mist, 346 small tanks were assembling in complete silence, their engines cold, crews waiting. Among them, 225 were Renault FDs, tiny two-man machines that German intelligence had dismissed as toys. Duffieux had fought at Verdun, survived the Nivelle offensive, watched countless attacks shatter against German machine gun positions. He'd seen British heavy tanks at Cambrai, massive rhomboid monsters that crossed trenches but moved at walking pace and broke down constantly. But these new French tanks were different. Small enough to hide behind farm buildings, light enough to cross bridges that would collapse under British behemoths, nimble enough to navigate shell-cratered terrain. What Duffieux couldn't know, what none of the 85,000 French and American soldiers preparing to attack could have imagined, was that these unglamorous little machines represented the most important revolution in ground warfare since the invention of gunpowder. Within hours, the Renault FT would shatter German defensive lines that had held for 4 years. Within months, its design would become the template for every tank built for the next 3 decades. Within a generation, the principles it established would decide the outcome of World War II. This is the story of how a revolutionary French designer, a skeptical military establishment, and the desperate circumstances of total war created a weapon that changed everything, how industrial logic defeated tactical orthodoxy, how one man's radical vision, initially rejected and mocked, became the foundation of modern armoured warfare, and how German generals watching those little tanks advance on July 18th realised, too late, that they were witnessing their own defeat. The Renault FT didn't just win battles, it invented a new way of fighting. To understand why the Renault FT was revolutionary, you must first understand what came before. When tanks first appeared on the Somme battlefield in September 1916, they represented Britain's desperate attempt to break the stalemate of trench warfare. The Mark I tank, designed by a naval committee with no understanding of land combat, was a 28-ton monstrosity shaped like a rhomboid. It carried its armament in sponsons protruding from the sides. The crew of 8 men worked in conditions that resembled a mobile hell. Temperature inside reached 120 degrees Fahrenheit. Engine fumes caused unconsciousness. The noise was so loud that crew members communicated by hitting each other with hammers to get attention. The tanks moved at 3 miles per hour maximum, barely faster than walking pace. They could cross trenches by virtue of their long tracks running completely around the hull, but they couldn't cross anything wider than 12 feet. They broke, down constantly. At Cambrai in November 1917, where 476 British tanks achieved initial breakthrough, over 180 broke down from mechanical failure before enemy action destroyed them. But the worst problem was tactical inflexibility. The guns were mounted in fixed sponsons. To aim, the entire tank had to turn. The commander, crushed into the hull with 7 other men, had minimal visibility and no way to coordinate with other tanks. Each tank operated essentially alone, unable to maneuver in response to changing battlefield conditions. The French, watching British tank development with interest, initially followed a similar path. The Schneider CA-1 and Saint-Chamond tanks, rushed into production in 1916 and 1917, were essentially boxes mounted on tractor chassis. The Schneider carried a 75-metre gun in a sponson on the right side. The Saint-Chamond mounted the same gun in the nose. Both were disasters. The Schneider was so poorly armoured that German armour-piercing bullets penetrated it easily. At Berry-au-Bac in April 1917, 57 Schneiders attacked. German artillery destroyed 44 in the first hour. Burning crews evacuated, only to be cut down by machine gun fire. Those that survived reported that the tank's design made it a death trap. The gun had limited traverse, vision was terrible, the fuel tanks were unprotected, and a single hit could transform the vehicle into an inferno. The Saint-Chamond was worse. At 23 tons, it was so heavy and so long that it couldn't cross trenches. The front-mounted gun gave it terrible balance. It frequently got stuck, nose down in shell holes, helpless target for German artillery. After the disastrous Chemin des Dames offensive in spring 1917, where Saint-Chamond proved almost useless, the French tank program was in crisis. General Philippe Pétain, newly appointed commander-in-chief was ready to cancel tank production entirely. The existing designs clearly didn't work. Perhaps the entire concept of armoured warfare was flawed. Then, in a workshop outside Paris, an automotive engineer who had never designed a weapon was finalising plans for a tank that would prove everyone wrong. Louis Renault was 40 years old in 1916, a successful industrialist who had built France's largest automobile company through innovation and ruthlessness. He'd pioneered the direct drive transmission, the pressurised cooling system, the monoblock engine. His cars had won races and earned profits. When the French government asked him to build tanks in 1916, Renault visited the front, studied the British and French designs, and reached a radical conclusion. Everyone was building tanks wrong. The prevailing wisdom treated tanks as mobile forts, heavy, heavily armed, designed to break through fortifications. Renault saw something different. He envisioned a light, fast, manoeuvrable vehicle that could exploit breakthroughs rather than create them. A tank that could support infantry directly, moving with them rather than leading them. Most revolutionary. Of all, he designed a tank with a fully rotating turret mounted on top of the hull. This decision, seemingly obvious in retrospect, was radical in 1916. Every existing tank mounted guns in fixed positions or limited traverse sponsons. Renault's design placed a single gun or machine gun in a turret that could rotate 360 degrees, allowing the vehicle to engage targets in any direction without turning the entire hull. The advantages were enormous. The tank could navigate rough terrain while keeping its gun pointed at threats. It could respond instantly to flanking attacks. Most importantly, the commander, positioned in the turret, could see the battlefield and direct the driver below, creating a two-man crew that worked as a team rather than 8 men stumbling over each other in darkness. Renault's design was small. The FT measured just 16 feet long, 5 feet wide, weighed 6.5 tons. Compared to the 28-ton Mark IV or E-23-ton Saint-Chamond, it seemed like a toy. German intelligence, when they first captured one, reported it was probably a training vehicle. Nothing that small could be a serious weapon. But the compact size was deliberate. A small tank could hide behind cover that would expose a large one. It could cross bridges that would collapse under heavy tanks. It could navigate narrow village streets where British rhomboids couldn't fit. Most importantly, it was cheap and fast to produce. Renault calculated that for the cost of one heavy tank, France could build 3 FTs. And quantity, he understood, mattered. The FT's armour was minimal by heavy tank standards, just 22mm of steel plate on the front, 16mm on the sides. But it was enough to stop rifle and machine gun fire, which killed most infantry. And by using cast steel for the turret and riveted plates for the hull, Renault created a production process that could be scaled rapidly. The engine was a Renault 4-cylinder producing just 39 horsepower. Critics said it was underpowered, but paired with the light weight, it gave the FT a power-to-weight ratio better than any contemporary tank. The FT could reach 7 miles per hour, more than twice the speed of British heavy tanks. In combat, that speed difference meant the FT could manoeuvre, react, and survive. Perhaps most importantly, Renault designed the FT with a rear-mounted engine and transmission. This configuration, absolutely standard in modern tanks, was revolutionary in 1916. It moved the hot, dangerous machinery away from the crew. It improved weight distribution. It allowed the turret to be centered on the hull, and it established the basic layout that every successful tank would follow for the next century. Engine in the rear, fighting compartment in the middle, driver in the front. When Renault presented his design to the French army in December 1916, the reaction was mixed. Some officers saw the potential, others dismissed it as too small, too lightly armed, too radical a departure from proven designs. General Jean-Baptiste Eugène Estienne, the French army's head of tank development and the closest thing France had to a tank visionary, was immediately convinced. Estienne understood that tanks weren't breakthrough weapons. They were exploitation weapons. Heavy tanks could cross the first trench line, but then what? They were too slow to exploit success, too vulnerable to artillery, too unreliable to sustain operations. But a light tank that could move with infantry, provide direct fire support and keep pace with an advance, that could change everything. Estienne became the FT's champion, fighting the skeptics within the French high command. But even with his support, production moved slowly. The French army, burned by the failures of the Schneider and Saint-Chamond, was reluctant to commit resources. Initial orders were for just 150 tanks, barely enough to equip 2 battalions. Then came Nivelle's disastrous offensive in April 1917. The French army promised a breakthrough instead suffered 187,000 casualties in 10 days. Mutinies swept through dozens of divisions. Soldiers, having endured 3 years of slaughter, refused to participate in more suicidal offensives. Pétain, replacing Nivelle, faced a crisis. The French army was on the verge of collapse. He needed to restore confidence, needed a weapon that could achieve results without pointless sacrifice. He needed something that worked. In June 1917, Pétain visited Renault's factory and saw the first completed FT prototype. He watched it maneuver through an obstacle course, cross a trench, rotate its turret to engage targets while moving. He climbed inside, experienced the superior visibility, the relative comfort, the mechanical reliability. Then he did something that would change the war. He ordered 3,500 Renault FTs, the largest single tank order in history to that date. Renault the industrialist had proven his design. Now came the harder part, building it. The production challenges were enormous. Renault's factory in Billancourt had to be completely reorganized. New buildings were constructed, assembly lines were created, suppliers had to be found for hundreds of components. The turret casting alone required new foundries. But Renault was a genius at production engineering. He'd studied American mass production techniques, understood assembly line principles, knew how to optimize manufacturing. He standardized components across the production line. He sourced parts from subcontractors across France, creating a supply network that distributed production and reduced vulnerability to disruption. He implemented quality control procedures that ensured reliability. By early 1918, the Billancourt plant was producing 22 FTs per day. Other manufacturers, brought into the program, added more capacity. The Berlier factory in Lyon, the Sommois plant in Paris, Delaunay-Belleville, all began building FTs from Renault's designs. By summer 1918, France was producing over 200 tanks per month, more than Britain and Germany combined. The FT began entering service in May 1918. The first crews, drawn from artillery and cavalry units, trained on the vehicles with a mixture of excitement and skepticism. The FT was unlike anything they'd experienced. The 2-man crew required perfect coordination. The commander in the turret controlled the gun and directed the driver. The driver in the front hull steered and managed the engine. They communicated through a speaking tube and by kicking each other's legs, since the engine noise made verbal communication nearly impossible. Drivers faced particular challenges. The FT was steered with a brake lever system that required strength and precision. To turn left, you pulled the left brake, locking the left track while the right track continued pivoting the tank. It was exhausting in combat. Visibility was minimal, just small vision slits that gave a narrow view forward. The driver navigated essentially blind, responding to the commander's directions. The commander in the turret had the better position but greater responsibility. He aimed and fired the gun, either a 37mm cannon or an 8mm Hotchkiss machine gun, depending on the tank's configuration. He watched for threats, directed the driver, coordinated with other tanks, and maintained situation awareness, all while standing in a tiny turret barely 4 feet in diameter, breathing engine fumes and cordite smoke deafened by mechanical noise. Training emphasized tactics that exploited the FT's advantages. Small size meant using terrain for cover. Speed meant keeping moving, never presenting a stationary target. The rotating turret meant engaging targets while maneuvering. Most importantly, FTs were trained to operate in groups, supporting each other, creating crossfire, overwhelming German positions through coordinated action. By July 1918, the French had assembled 30 battalions of Renault FTs, over 3,000 tanks organised into units of 75 vehicles each. But they'd seen only limited action, small probing attacks that showed promise but proved nothing definitive. The true test was coming. And it would occur at Soissons. In July 1918, Germany had exhausted itself. The spring offensives, Ludendorff's desperate gamble to win the war before American forces arrived in strength, had gained ground but failed to achieve breakthrough. German armies were overextended, supplies were running short, and the troops were exhausted. General Ferdinand Foch, Supreme Allied Commander, saw an opportunity. The German salient at Château-Thierry bulged into Allied lines, supplied by rail lines running through Soissons. A strike from the west cutting those rail lines would trap German forces and force a major retreat. The French 10th Army under General Charles Mangin was assigned the main attack. Mangin, known as the Butcher for his willingness to accept heavy casualties, was also surprisingly innovative. He'd studied tank warfare, understood the potential, and most importantly understood timing. Secrecy was crucial. The Germans couldn't know an attack was coming, so Mangin assembled his forces at night, moving units into attack positions under cover of darkness. The 225 Renault FTs assigned to the assault were brought forward on transporters, engines silent, hidden in the Retz forest. No reconnaissance flights that might alert Germans. No preliminary bombardment that would announce the attack. Just silence, darkness, and waiting. At 4:35 a.m. on July 18, 1918, the attack began. First, a sudden artillery barrage, 5 minutes of concentrated fire that stunned German positions. Then, silence. Then, the tanks. Pierre Duffieux, the infantry captain waiting in his trench, saw them emerge from the mist. Rows of small tanks moving faster than he'd imagined possible, their engines creating a low rumbling growl that reminded him of distant thunder. Behind each tank, infantry sections advanced in loose formation, using the vehicles as mobile cover. The FTs moved in groups of 3, a section commanded by a lieutenant whose tank carried a small flag. The groups advanced in bounds, some moving while others provided covering fire. It was coordinated combined arms warfare, the kind of operation that armies had theorized about but never executed. The first German position, a line of trenches and machine gun nests, opened fire at 500 yards. Machine gun bullets sparked off the FT's armour, doing no damage. German infantry, veterans who'd stopped countless attacks with rifle and machine gun fire, were helpless. Their bullets couldn't penetrate. Their grenades, thrown desperately as tanks rolled past, lacked the force to damage armoured vehicles. Lieutenant Heinrich Stauber of the 231st Infantry Division watched the attack from his command dugout. Years later, in a prisoner interrogation, he described what he saw. The small tanks came out of nowhere, no warning, one moment silence, the next moment they were on top of us. We fired everything we had. The tanks didn't stop, they just kept coming. Some drove directly over the trenches, trapping men below. Others stopped and fired into the trenches with machine guns, but most just drove past us, leaving us surrounded. My men, brave soldiers who'd fought for 3 years, panicked. They couldn't fight something their weapons couldn't hurt. They surrendered or ran. The position was lost in 15 minutes. An FT equipped with a 37mm cannon approached a German machine gun bunker. The commander identified the target through his vision slit. The driver stopped, locking one track and pivoting the tank to give the gunner a clear shot. The 37mm gun, designed specifically for this role, fired high explosive shells perfect for destroying fortifications. 1 round. The bunker's firing slit disappeared in a shower of concrete fragments. The machine gun fell silent. The tank moved on. Another FT, carrying a machine gun in its turret, engaged German infantry attempting a counterattack. The Hotchkiss machine gun, the same, reliable weapon French infantry had used since 1914. Fired from a stable platform with perfect visibility. German soldiers, advancing across open ground, were cut down in seconds. Unlike infantry machine gunners who could be suppressed by return fire, the tank's gunner was protected by armour. He could fire continuously, methodically, without fear. The combination was devastating. Where British heavy tanks had lumbered across battlefields at walking pace, easily targeted by artillery, the Renault FTs moved at 7 miles per hour, fast enough to complicate German targeting. Where heavy tanks had operated individually, each one an isolated fortress, the FTs worked in groups, supporting each other, creating overlapping fields of fire. By 7 a.m, the French infantry had advanced 3 miles, unprecedented progress on the Western Front where gains were typically measured in yards. The FTs were operating beyond the first German defensive line, in the support trenches where German reserves were supposed to organise counterattacks. But those reserves, equipped only with rifles and machine guns, couldn't stop tanks. German artillery, the usual defence against tanks, was in disarray. The speed and surprise of the attack had given gunners no time to register targets. By the time artillery positions received ranging information, the French tanks had moved, and the FT's small size made them difficult targets. British rhomboids, tall and massive, could be hit at long range. The low-profile Renaults, hull down behind terrain features, were nearly invisible until they were on top of you. Captain Dufeux, advancing behind a group of FTs, watched one engage a German 77mm field gun that had been turned to fire directly at the tanks. The artillery crew, brave men doing their desperate duty, loaded and fired. The shell hit the lead FT directly on the front armour. The tank stopped, smoke pouring from the hit. Dufeux thought it was knocked out. Then the turret traversed, the 37mm gun fired, and the German artillery piece disappeared in the explosion. The FT, its armour dented but not penetrated, advanced over the wrecked gun position. Later inspection showed the shell had struck at a slight angle, deflecting rather than penetrating. The cast steel turret, Renault's innovation, had distributed the impact force. The tank was repairable. German accounts from July 18th consistently mention the psychological impact of the FTs. Unlike the British heavy tanks, which inspired fear but also a degree of respect for their impressive size, the small French tanks created a different reaction. They seemed unstoppable because they were everywhere. You couldn't focus on one tank because 3 more were flanking your position. You couldn't retreat because tanks were already in your rear areas. The speed and numbers created an overwhelming sense of being surrounded, of fighting a battle already lost. By midday, French forces had advanced 6 miles, reaching the outskirts of Soissons. The German defenders, an army that had held its positions for 4 years, were in full retreat. The 10th Army had achieved complete breakthrough. American forces attacking from the south achieved similar success. The Marne salient was collapsing. General Ludendorff, at German High Command, received reports with disbelief. A breakthrough wasn't possible. The defensive positions were too strong. Then the details arrived. Hundreds of light tanks, too fast for artillery, too numerous to stop, operating in coordination with infantry and artillery. The reports used a new word, Panzerwagen, armoured vehicle, but they described something unprecedented. For the first time, German commanders were reporting that they couldn't stop an attack. Not that the attack was expensive to stop, or difficult to stop, but that their weapons and tactics were insufficient. The following days confirmed the disaster. French and American forces continued advancing. The Germans evacuated the entire salient, abandoning positions, supplies, equipment. The rail lines through Soissons were cut. German armies north of the Marne had to retreat or face encirclement. By July 21st, the Germans had fallen back to their starting positions from the spring offensives. Months of gains, purchased with hundreds of thousands of casualties, were lost in 3 days. The strategic situation had shifted decisively. More ominously for Germany, the tactical lessons of Soissons were being studied by Allied commanders across the front. The Renault FT had proven that light tanks, operating in large numbers with proper combined arms support, could break through defensive positions that had resisted everything else. The stalemate of trench warfare was over. The question was no longer if the Allies would break through German lines, but when. Of the 225 Renault FTs that attacked at Soissons, 102 were damaged or destroyed by the end of the first day, but 50 of those were repairable. Mechanical breakdowns accounted for 31 vehicles. German fire accounted for only 21 complete losses, a remarkable survivability rate. More importantly, the damaged tanks were recovered, repaired, and returned to service. Within a week, tank strength was back to pre-battle levels. This logistical reality, impossible with heavy tanks that required specialized recovery equipment, meant the FT force was sustainable. You could lose tanks in battle and replace them. The production pipeline was producing more tanks than combat losses could destroy. After Soissons, orders for the Renault FT exploded. The French increased their orders to 7,120 tanks. The Americans, initially planning to build heavy tanks, cancelled those programs and ordered 4,240 FTs to be built in the United States. The Italians ordered 1,400. Even the British, committed to their heavy tank philosophy, ordered 300 for evaluation. The global tank production was converging on Renault's design. In August and September 1918, Renault FTs participated in every major French offensive. The Second Battle of the Marne, the reduction of the Amiens salient, the breaking of the Hindenburg line, everywhere the pattern was the same. Surprise assembly, dawn attack, rapid breakthrough. German defensive doctrine, perfected over 4 years of war, had no answer for massed light tanks. General Estienne, the FT's early champion, wrote in his after-action report from the Soissons battle, "The light tank has proven itself the decisive weapon. Its advantages over heavy tanks are so pronounced that future tank production should focus exclusively on light, mobile vehicles. The tank's purpose is not to break through fortifications but to exploit breakthroughs, to maintain momentum, to prevent the enemy from stabilizing defensive lines. In this role, speed and numbers matter more than individual firepower or armor." But it was in the details of combat employment that the FT's true revolution became clear. Renault had created not just a new weapon, but a new system of warfare. The rotating turret, dismissed by some as a minor technical detail, had profound tactical implications. A tank with a fixed gun had to choose between moving and fighting. It could advance or it could engage targets, but doing both simultaneously was nearly impossible. The FT could navigate rough terrain, maintain forward momentum, and engage threats from any direction without stopping. This meant FT units could maintain initiative, constantly pressuring defenders, never presenting a predictable target. The two-man crew, seemingly a disadvantage compared to the eight-man crews of heavy tanks, actually improved combat effectiveness. In a heavy tank, 8 men working in impossible conditions struggled to coordinate. Orders were misheard or ignored. Situational awareness was minimal. In the FT, 2 men developed almost telepathic coordination. A veteran crew could identify targets, maneuver for position, and engage without verbal communication. The commander kicked the driver's left shoulder, turn left, right shoulder, turn right, head, stop, simple, reliable, effective. The French developed doctrine around these capabilities. FT tactics emphasized section-level coordination. 3 tanks operating as a team could suppress, flank, and destroy positions that a single tank, even a heavy one, would struggle to defeat. 1 tank fires, fixing the enemy's attention. The other 2 maneuver to flanks, approaching from unexpected directions. Converging fire from multiple angles overwhelms defenders. It was fire and maneuver at the tank section level. Combined arms warfare executed by vehicles instead of infantry squads. The Germans, analysing captured FTs and interrogating captured crews, understood immediately that they were facing a technological and tactical revolution. In September 1918, German High Command issued urgent directives for anti-tank warfare. Establish anti-tank guns in depth, create obstacles to channel tanks into killing zones, train infantry in close assault, tactics using grenades and mines, dig wider trenches that light tanks can't cross. But these countermeasures required resources Germany didn't have. Anti-tank guns were artillery pieces reassigned from other roles, weakening the artillery force. Obstacles required wire and steel that wasn't available. Training took time the German army didn't have, and widening trenches assumed a stable front, but the front was collapsing. More seriously, the countermeasures assumed the Allies would continue using tanks the same way. They didn't. French doctrine evolved rapidly, incorporating lessons from each battle. FTs began operating in larger formations, company and battalion strength attacks that overwhelmed local defences through sheer numbers. They learned to use terrain more effectively, approaching through dead ground where German observers couldn't see them. They developed combined arms techniques, coordinating with artillery for suppression, with infantry for consolidation, with aircraft for reconnaissance. By October 1918, German soldiers called the Renault FT Höllenhund, Hellhound, a creature that hunted them relentlessly. Its appearance on the battlefield was the signal that a position couldn't be held, that retreat was the only option. Morale, already fragile after 4 years of war and failed offensives, collapsed when FTs appeared. Units that had fought ferociously against infantry attacks surrendered immediately when faced with tanks they couldn't stop. The FT's impact extended beyond the battlefield. In factories across France, the production system Renault had created was proving the power of standardization and mass production. The FT was built from interchangeable parts. Any turret fit any hull. Any engine could be installed in any chassis. This meant damaged tanks could be repaired quickly by swapping components. It meant maintenance was simplified. It meant training was more efficient because crews could move between vehicles without retraining. American engineers studying the FT's production system were so impressed they tried to replicate it. The American automotive industry, already the world's most advanced in mass production, recognized the FT's manufacturing approach as even more sophisticated than their own methods. Ford, Packard, and General Motors engineers visited Renault's factories studied the assembly processes, adopted the techniques. When America began its own tank production program, it was based entirely on Renault's design and manufacturing philosophy. The British, more slowly, began to understand. In September 1918, the British Tank Corps conducted comparison trials between the Mark V heavy tank and captured Renault FTs. The results were sobering for advocates of heavy tanks. In mobility trials, the FT was superior on all terrains except flat open ground. In reliability trials, the FT's mechanical failure rate was 1/3 that of the Mark Vs. In production analysis, Britain could build 3 FTs for the cost of 1. Mark V. Most damning was the crew survey. Crews who had operated both tanks overwhelmingly preferred the FT. Despite its cramped interior and basic amenities, it was easier to drive, easier to fight, and more likely to bring them home alive. The British began planning their own light tank program, though it wouldn't reach production before the war ended. In Italy, the FT arrived just in time for the Battle of Vittorio Veneto in October 1918. The Italians had no native tank production and had relied on French heavy tanks with poor results. The FTs, operated by French crews initially, and then by Italian crews after abbreviated training, proved ideal for Italian terrain. Mountains, rivers, narrow roads, all the features that made heavy tanks impractical, were navigable by the light FTs. At Vittorio Veneto, FTs operating with Italian infantry broke through Austrian defensive lines and pursued the retreating enemy for miles. Austrian soldiers who had never faced tanks before surrendered en masse. The Austrian army, already on the verge of collapse from internal political tensions, disintegrated. Within 2 weeks, Austria-Hungary was requesting an armistice, but perhaps the most significant impact of the Renault FT was strategic. In the fall of 1918, German High Command faced a terrible calculation. The Allies could now break through any defensive position. The only question was where and when. Defending everything meant defending nothing. Concentrating forces meant leaving other sectors vulnerable to breakthrough. The Schlieffen Plan, Germany's strategic doctrine, had assumed that tactical superiority could offset strategic disadvantage. German units, better trained and led, could defeat larger enemy forces through superior tactics. The FT had invalidated that assumption. Tactical superiority didn't matter when the enemy could concentrate overwhelming force at the point of attack. Quality couldn't overcome quantity when quantity was also quality. By early November, German forces were in general retreat. The Hindenburg Line was broken. Allied armies were advancing toward Germany's borders. Revolution was breaking out in German cities. The navy was mutinying. And reports from the front indicated that soldiers were surrendering rather than fighting, specifically surrendering when tanks appeared. On November 9th, Kaiser Wilhelm II abdicated. On November 11th, Germany signed the armistice. The war was over. In the final accounting, the Renault FT had participated in combat for just 6 months, from May to November 1918. But in that time, it had become the most important weapon of the war's final phase. Over 3,000 FTs saw combat on the Western Front, Italian Front, and in smaller numbers on other fronts. They participated in every major Allied offensive of 1918. The production total by war's end was 3,194 completed tanks, with thousands more in production. But the FT's real impact came after the war, because Renault's design became the template for the future. In 1919, the victorious Allies found themselves with thousands of tanks and no immediate enemy. Most nations scrapped their heavy tanks. Too expensive to maintain, too specialized for peacetime use, too limited in tactical application. But they kept their Renault FTs. France retained over 2,000 in service. The United States kept 950. Poland received 120. Italy kept 200. Japan bought 13 as a basis for their own tank program. Even the Soviet Union, soon to be France's ideological enemy, purchased several for study. Why did everyone keep the FT? Because it was cheap to operate, simple to maintain, and versatile enough for peacetime roles. FTs served as training tanks, teaching new generations of tankers. They were used for colonial policing in North Africa and Indochina. They participated in dozens of small wars and interventions throughout the 1920s. But more importantly, every nation that studied tank warfare in the interwar period started with the FT as their baseline. When Britain developed the Vickers light tank in the 1920s, it followed the FT's configuration: engine in the rear, turret in the middle, driver in the front. When America designed the M1 combat car in the 1930s, it used the FT's layout. When the Soviet Union created the T-18, their first indigenous tank design, it was a direct copy of the FT with minor modifications. When Germany, forbidden to build tanks under the Versailles Treaty, secretly developed prototypes in the 1920s, they studied captured FTs and adopted the same basic configuration. The FT's influence extended to tactics and doctrine. Heinz Guderian, the German officer who would later create the blitzkrieg doctrine, studied FT operations in 1918 as a young staff officer. He understood that the FT's success came from combining mobility, firepower, and shock action. His theories of armoured warfare, developed in the 1920s and 30s, were direct descendants of the combined arms tactics the French had pioneered with the FT. General George Patton, who commanded American tanks equipped with FTs in 1918, built his entire understanding of armoured warfare on lessons learned from those 6 months of combat. His doctrine of aggressive manoeuvre, of maintaining momentum, of using tanks to exploit rather than create breakthroughs, was FT doctrine adapted to larger, faster tanks. Basil Liddell Hart, the British military theorist who influenced tank development across the world, wrote in 1925, "The Renault FT was the first true tank. Everything before it was an experiment. Everything after it was a development. The basic configuration that Renault established, turret-mounted gun, rear engine, frontal driver position, has proven so successful that no serious alternative has emerged." The technical innovations of the FT became industry standard. Every successful tank design for the next 30 years featured a rotating turret. The rear engine configuration became universal. The 2 or 3 man crew arrangement with a commander and the turret directing a driver in the hull remained standard until the 1960s. Even details like the FT's sprung track system and its cast turret construction were copied worldwide. In the Spanish Civil War of 1936 to 1939, Renault FTs saw combat again, nearly 20 years after they were built. Republican forces used FTs alongside Soviet T-26 tanks against nationalist forces equipped with German Panzer Is and Italian CV-33 tankettes. The FT was obsolete by 1936 standards, its armour too thin for modern anti-tank weapons, its speed too slow, its gun inadequate. But it was still recognisably the same type of vehicle as its more modern opponents. Same configuration, same tactical role, same operational concept. The newer tanks were faster, better armoured, more reliable, but they were evolutionary developments, not revolutionary changes. When German forces invaded Poland in September 1939, beginning World War II, their tank force consisted primarily of Panzer I and II light tanks that traced their design lineage directly to the FT. The Panzer III and IV medium tanks that would become famous later in the war followed Renault's configuration even more closely. Turret-mounted gun, rear engine, frontal driver position. The tactical doctrine the Germans employed, combined arms coordination between tanks, infantry and artillery, was an elaboration of tactics the French had developed with FTs in 1918. The supreme irony was that when Germany invaded France in May 1940, French forces still had approximately 500 Renault FTs in service. These 22-year-old tanks, obsolete but still functional, were deployed in defensive roles. Some fought. Against German anti-tank guns and modern panzers, they stood no chance. But in a few instances, when FTs encountered German reconnaissance units equipped only with light weapons, the old tanks still proved effective. A machine gun nest protected by 16mm of armour was still a machine gun nest. The FT's combat career finally ended in 1940, but its influence continued. The American M4 Sherman tank that would become the Allied workhorse in World War II followed the FT's configuration. The Soviet T-34, arguably the best tank of the war, was a direct descendant of designs that traced back to the FT through the T-18 and BT series. The German Tiger and Panther tanks, the most feared armoured vehicles of the war, used the TER configuration Renault had pioneered. Post-war designs continued the lineage. The American M48 Patton, the British Centurion, the Soviet T-54, every major tank design of the 1950s and 60s followed the basic layout that Renault had established in 1916. It wasn't until the 1960s, with the development of main battle tanks like the British Chieftain and American M60, that significant departures from Renault's template appeared, and even then the basic configuration remained. Today, the M1 Abrams, Leopard 2, Challenger 2, and other modern main battle tanks still place the engine in the rear, the turret in the middle, and the driver in the front. They still use rotating turrets with 360-degree traverse. They still employ a crew divided between turret and hull. The details have changed enormously, but the fundamental architecture that Louis Renault designed over a century ago remains optimal. The FT's influence extended beyond hardware to military culture. The French tank service, created around the FT, established traditions of aggressive manoeuvre and combined arms cooperation that influenced armour forces worldwide. The American armour branch traces its lineage to the Tank Corps of 1918, trained and equipped with FTs. The German Panzerwaffe, rebuilt in the 1930s, studied FT operations as case studies in mobile warfare. Even the Soviet Union's tank forces, despite their ideological opposition to capitalist France, based their doctrine on lessons from 1918, where FTs had demonstrated the decisive potential of armoured warfare. The FT established principles that remain valid. Mobility provides survivability. Firepower concentrated at the point of attack achieves breakthrough. Mechanical reliability is as important as combat capability. Simplicity of design enables mass production. Standardization improves logistics. These seem obvious now, but they were revolutionary in 1918. At the United States Army Armor School at Fort Moore, Georgia, the history of armoured warfare begins with a display featuring a restored Renault FT. The placard reads, "The first modern tank." The Renault FT established the configuration and tactical employment of armoured vehicles that remain standard today. Every tank since 1918 is a descendant of this design. At the Musée des Blindés en Saumur, France, the world's largest tank museum, the Renault FT occupies the place of honour in the World War I gallery. Surrounding it are the heavy tanks of the era, British Mark IVs and Vs, German A7Vs, French Saint-Chamond. All of them dead ends, designs that led nowhere. The FT alone led to the future. In Renault's archives, preserved in the company museum at Boulogne-Billancourt, are Louis Renault's original design sketches from 1916. They show a man thinking systematically about the problem of mobile warfare, weight calculations, power-to-weight ratios, armour penetration tables, production cost estimates, vision arc diagrams. He wasn't designing a weapon, he was engineering a system, and that system worked so well that it became the foundation of armoured warfare for a century. Louis Renault received little credit during his lifetime. He was a businessman, not a soldier. His tank was seen as just one weapon among many in France's arsenal. After his death in 1944, under controversial circumstances during the liberation of France, his legacy became complicated by collaboration accusations. But the FD remained, in museums, in military histories, in the DNA of every tank that followed. The German pilots who laughed at the P-47 Thunderbolt in 1943 were repeating the mistake their fathers had, made in 1918. They saw an ungainly machine that didn't fit their preconceptions of what a fighter should be, and they dismissed it. Just as German soldiers in 1918 had seen a small, odd-looking tank that didn't fit their idea of what a tank should be, and they dismissed it, until it rolled over their positions and they realised their mistake too late. On July 18, 1918, Captain Pierre Duffieux watched those small tanks emerge from the morning mist and knew immediately that something fundamental had changed. The war wouldn't end in stalemate. The defensive advantage that had made the Western Front a killing ground for 4 years was over. Mobility had returned to warfare, and mobility, he understood, would decide all future wars. He was right. The Renault FT didn't just win battles, it invented the way battles would be won for the next 100 years. And when you see a modern main battle tank with its rear engine and centred turret and rotating gun, you're seeing Louis Renault's vision, proven on a July morning in 1918, still decisive in the 21st century. The revolution didn't announce itself. It arrived in the pre-dawn darkness, small and unassuming, and changed everything. The years immediately following World War I revealed just how completely the Renault FT had transformed military thinking. In 1919, the newly formed League of Nations commissioned a study of weapons that had proven decisive in the war. The report, compiled by military observers from 23 nations, identified 3 weapons that had fundamentally altered warfare: the machine gun, poison gas, and the light tank. But while machine guns had made defense dominant and poison gas had been largely ineffective, the light tank had restored offensive capability. The report specifically cited the Renault FT as the weapon that broke the stalemate. Poland's experience demonstrated the FT's versatility beyond Western Front trench warfare. In 1920, during the Polish-Soviet War, Polish forces equipped with 120 FTs faced Bolshevik cavalry armies that had overwhelmed conventional infantry. At the Battle of Warsaw in August 1920, Polish FTs operating in combined arms groups stopped Soviet cavalry charges that had previously been unstoppable. Soviet commander Semyon Budyonny, whose legendary cavalry had rampaged across Ukraine, found his horsemen helpless against armoured vehicles that machine gun fire couldn't harm. A Polish after-action report noted, "The tank renders cavalry obsolete. A single FT section can defeat a cavalry regiment. The horse, dominant in warfare for 4,000 years, has been replaced in a single generation." The Soviets learned this lesson thoroughly. After their defeat at Warsaw, Soviet military theorists began intensive study of tank warfare. Mikhail Tukhachevsky, the young commander who had led the failed offensive on Warsaw, became an advocate for mechanized warfare. He studied French employment of the FT, analyzed the tactical innovations, and developed theories of deep operations that would become Soviet doctrine. When Stalin ordered creation of Soviet tank forces in the late 1920s, Tukhachevsky's concepts provided the foundation. The Red Army purchased FTs from France, reverse-engineered them, and produced the T-18, a near-identical copy. By 1930, the Soviet Union had more tanks than the rest of the world combined, all based on a design created by a French capitalist industrialist. In North Africa, French colonial forces used FTs to suppress rebellions that conventional forces couldn't contain. In Morocco, Abdelkrim's Riffian fighters had defeated Spanish colonial armies and were threatening French territory. The Riffians, skilled mountain fighters with modern rifles, had mastered guerrilla tactics that frustrated European infantry. In 1925, French forces deployed FTs into the Rif Mountains, using them as mobile fortresses that could advance through hostile terrain while providing covering fire. The psychological impact was immediate. Riffian fighters, brave men who would charge machine gun positions, fled from the small tanks. Their rifles couldn't penetrate the armour. Their cover, effective against infantry, was useless against vehicles that could simply drive over it. The rebellion collapsed within months. The FT's adaptability surprised even its advocates. In Indochina, French forces modified FTs for jungle warfare, adding tropical cooling systems and clearing equipment. In Syria, FTs operated in desert conditions that should have overwhelmed their cooling systems. In China, several FTs were operated by warlord armies who had purchased them from French surplus stocks. Each environment revealed new capabilities. The basic design was so sound that it could be adapted to almost any condition. But the most significant post-war development was doctrinal. Military theorists worldwide studied the 1918 campaigns, trying to understand why tactics that had failed for 4 years suddenly succeeded in 6 months. The answer increasingly pointed to the FT. Not because it was invulnerable, it wasn't. Not because it was overwhelmingly powerful, individual FTs were quite vulnerable to artillery, but because it changed the tactical calculus. Before the FT, attackers had to cross open ground while defenders fired from cover. The advantage was decisively with the defender. The FT reversed this. Now attackers advanced under armour, while defenders tried desperately to damage fast-moving targets with weapons designed for stationary targets. The advantage had shifted to the attacker, and warfare would never be the same. Captain Basil Liddell Hart, who had served as an infantry officer on the Western Front and suffered gas poisoning, devoted his post-war career to understanding the FT's impact. His 1927 book, The Remaking of Modern Armies, included an entire chapter on the FT, titled The Tank That Won the War. Liddell Hart interviewed French tank commanders, studied German defensive records, and analysed casualty statistics. His conclusion was stark. The Renault FT achieved in 6 months what 4 years of conventional tactics could not. It broke the defensive stalemate not through superior firepower. We had tried that with artillery barrages, not through superior numbers. We had tried that with mass infantry attacks, but through mobile protected firepower. The tank allowed infantry to advance without being annihilated. This simple fact changed everything. Liddell Hart's writings influenced a generation of military thinkers. In Germany, where the Versailles Treaty forbade tank production, young officers studied his work and planned for a future when Germany would rearm. Major Heinz Guderian, serving in a deceptively named motorized transport unit, was reading everything available about tank warfare. His copy of Liddell Hart's book, preserved in the German military archives, is heavily annotated. Next to a paragraph about FT tactics at Soissons, Guderian wrote in the margin, "This is the future, not breakthrough but exploitation, not breakthrough tanks supported by infantry, but breakthrough by combined arms with tanks as the decisive element." The irony was profound. Germany, defeated partly by the Renault FT, would rebuild its military around principles the FT had established. When German rearmament began in the 1930s, their first tanks, built in secret and designated as agricultural tractors to evade treaty restrictions, were light vehicles following the FT configuration. The Panzerthal, Germany's first production tank, was essentially an updated FT with better armour and a more powerful engine. German tank doctrine, developed by Guderian and other theorists, emphasised the same principles French commanders had pioneered with the FT: speed, concentration, combined arms coordination. In Britain, the military establishment was slower to embrace the lessons. The Royal Tank Corps, proud of their heavy tanks and the initial breakthrough at Cambrai, resisted the shift toward light tanks. But practical considerations forced change. Heavy tanks were expensive to build and maintain. Light tanks, following the FT model, were affordable. By the early 1930s, Britain was producing Vickers light tanks that were direct descendants of the FT concept. When the British Army mechanised in the 1930s, replacing cavalry with armoured vehicles, it was the light tank, not the heavy tank, that formed the core of the new force. The United States took longest to absorb the lessons, partly because American involvement in World War I had been brief, partly because isolationism made military development a low priority. The 950 FTs in American service were used primarily for training through the 1920s, but American officers who had commanded FTs in combat, including George Patton and Dwight Eisenhower, understood their significance. Patton, in a 1922 lecture at the Army War College, stated, "The light tank is to modern warfare what the horse was to ancient warfare, the means by which decision is achieved. Heavy tanks may create breakthrough. Light tanks exploit it, and exploitation is what wins wars." Eisenhower, who had commanded the Army's tank training center during World War I without seeing combat, spent the 1920s writing papers about tank warfare that his superiors mostly ignored. One paper, written in 1924 and unearthed decades later, outlined a theory of armoured warfare nearly identical to what the Germans would implement as blitzkrieg 15 years later. Tanks should operate in mass, concentrated at decisive points. They should be supported by motorised infantry and artillery. The objective is not to destroy the enemy army, but to disrupt its command and logistics, creating collapse through paralysis rather than destruction. These were FT tactics scaled up to army level. Japan's adoption of the FT revealed another aspect of its influence. Japan had no indigenous tank development and limited understanding of armoured warfare. In 1927, they purchased 13 Renault FTs from France and used them as the basis for their tank program. Japanese engineers carefully measured every component, studied every system, and created detailed technical drawings. The result was a series of Japanese tanks that, while incorporating improvements, followed the FT template. The Type 89 medium tank, Japan's primary armoured vehicle through the 1930s, had an FT-derived layout and similar tactical role. When Japanese armour engaged Soviet tanks in border clashes at Khalkhin Gol in 1939, it was descendants of the FT fighting other descendants of the FT, a family conflict of Renault's design children. The global proliferation of FT-derived tanks created a situation unique in military history. By the mid-1930s, every major military power was fielding tanks based on the same basic design. French, German, Soviet, British, American, Italian, and Japanese tanks all shared the fundamental configuration Renault had established. Differences existed in armour thickness, gun calibre, speed, and reliability, but the core concept was universal. This standardization accelerated tactical development. Lessons learned by one nation's tank force were applicable to others. Doctrines developed in one country could be studied and adapted elsewhere. Tank warfare became a discipline with common principles, much as infantry warfare had been for centuries. The Spanish Civil War provided the first large-scale test of these evolved tank doctrines. Soviet T-26 tanks, FT descendants, faced German Panzers, also FT descendants, in battles that previewed World War II. The lessons were studied intensely by military observers from all major powers. Soviet tanks, operating with proper infantry support and using terrain for cover, proved effective. German tanks, initially used in small groups without coordination, suffered heavy losses. Both sides adapted, developing tactics that would later be employed on a larger scale. The fundamental insight was that the FT's principles still applied. Tanks were most effective when concentrated, when operating with combined arm support, when used to exploit success rather than create it. By 1939, 21 years after the FT's combat debut, virtually every military theory about armoured warfare traced back to the 1918 campaigns. The details had evolved. Tanks were faster, better armed, more reliable. Radios allowed coordination impossible in 1918. Doctrine had become more sophisticated, but the core principles remained Renault's. Mobility creates opportunity. Concentration achieves breakthrough. Combined arms ensure success. These weren't new insights in 1939. They had been proven at Soissons in 1918. When World War II began, the Renault FD's influence was everywhere. German panzer divisions using blitzkrieg tactics were executing operational concepts developed from studying FD operations. Soviet deep battle doctrine, which would eventually defeat Germany, derived from Tukhachevsky's analysis of French tank employment in 1918. American armoured doctrine, developed by men who had commanded FDs in combat, emphasized the same aggressive exploitation that had characterized the FD's use. Even minor powers like Romania, Hungary and Finland fielded tanks that traced their lineage to the FD. The actual FDs still in service in 1940 were hopelessly obsolete. Their 16mm side armour couldn't stop modern anti-tank guns. Their 37mm guns couldn't penetrate modern tank armour. Their top speed of 7 miles per hour was absurdly slow compared to 1940-era tanks, reaching 25 miles per hour. But obsolescence of the hardware didn't diminish the design's influence. Every tank that defeated the obsolete FTs was itself an evolution of Renault's concept. In the occupied zone of France after 1940, German forces actually used captured FTs for occupation duties. The small tanks were employed for guarding installations, convoy escort and anti-partisan operations. They were effective in these limited roles precisely because they retained the advantages that had made them successful in 1918. Armour-proof against small arms, all-around firepower from the rotating turret, mechanical simplicity that made field maintenance possible. German soldiers operating these captured tanks reported that, for static defensive missions, the 22-year-old design was still adequate. The final combat use of Renault FTs came in unexpected circumstances. When Allied forces landed in Syria and Lebanon in 1941 to prevent Vichy French forces from supporting Germany, both sides were equipped with FTs. Free French and British forces used FTs in supporting roles. Vichy French forces deployed FTs in defensive positions. The battles were small-scale, and the FTs were marginal participants, but the historical irony was rich. The tank that had helped win World War I was present on both sides in World War II. After 1945, surviving FTs became museum pieces and monuments. France preserved dozens in military museums. The United States kept several at the Ordnance Museum and West Point. Individual FTs were mounted on pedestals in town squares across France, memorials to the Great War. But their real memorial was functional, not commemorative. Every tank on every battlefield in World War II, Korea, Vietnam, and subsequent conflicts was a descendant of the FT. The configuration Renault had pioneered remained optimal through generations of technological change. Modern tank designers, working with composite armour, digital fire control and gas turbine engines, still begin with Renault's layout. The M1 Abrams, entering service in 1980, placed its turbine engine in the rear, its turret in the centre, its driver in the front, exactly as the FT had 64 years earlier. The configuration worked in 1918 and still works in the 21st century because it represents the optimal solution to the problem of mounting a rotating gun on a mobile armoured platform. Military historians analysing the FT's impact have compared it to other revolutionary weapons. The machine gun changed defensive warfare, but didn't solve the stalemate it helped create. The aircraft created a new dimension of warfare, but didn't decide ground battles. Poison gas was a failed experiment, too unpredictable and too easily countered. The tank, specifically the light tank, as exemplified by the FT, broke the stalemate and restored mobility to warfare. In terms of strategic impact, only a few other weapons compare: the stirrup, which created medieval cavalry, the rifle, which ended the dominance of formed infantry, and the atomic bomb, which made total war between great powers too dangerous to contemplate. The FT's influence extended into unexpected areas. The automotive industry learned from Renault's production techniques. The assembly line methods he developed for tank production were adapted to peacetime vehicle manufacturing. The interchangeable parts philosophy became industry standard. Quality control procedures pioneered for military production improved civilian manufacturing. The organizational methods required to coordinate hundreds of subcontractors supplying components for the FT taught lessons applicable to all complex manufacturing. Strategically, the FT resolved one of history's great debates. For centuries, military theorists had argued about offensive versus defensive advantage. Sometimes, as with the Roman legion or Napoleonic column, offensive tactics dominated. Other times, as with the medieval castle or the rifle-armed defender, defensive positions were nearly impregnable. World War I represented the ultimate expression of defensive dominance. Machine guns, barbed wire, and artillery made attacks suicidal. The FT broke this dominance permanently. After 1918, defensive positions could always be broken if attackers had sufficient resources and proper equipment. The strategic implications were profound. Nations could no longer hide behind fortifications. The Maginot Line, built by France at enormous cost in the year 1930s, was obsolete before completion because tanks could simply go around it. Static defence had become impossible. This shift toward offensive capability made World War II inevitable in some analyses. Germany, denied the tools of offensive warfare by Versailles, rebuilt its military around the tank specifically to enable offensive operations. The blitzkrieg wasn't just a tactical innovation, it was a strategic necessity for a nation that couldn't afford prolonged defensive warfare, and blitzkrieg was possible only because the tank had restored offensive potential. The FT, designed to end World War I, inadvertently enabled World War II by proving that mobile armoured warfare could achieve rapid, decisive victory. The human cost of the FT's success is worth considering. At Soissons, the breakthrough achieved with FT support resulted in far fewer casualties than equivalent operations earlier in the war. The traditional infantry assault on fortified positions caused appalling losses, sometimes 50% casualties for minimal gain. At Soissons, French forces achieved a 6-mile advance on the first day with casualties under 10%. The FT saved lives by making attacks more effective and less costly. Over the final 6 months of the war, as FTs became increasingly common, Allied casualty rates decreased significantly, while advances increased. The tank didn't make war humane, nothing could, but it made offensive operations less suicidal. For the crews who operated FTs, the experience was transformative. These were men, mostly in their early 20s, who had survived the meat grinder of trench warfare. They had watched friends die in pointless attacks, had lived in mud and filth, had experienced the helplessness of being pinned by machine gun fire with no ability to fight back. The FT gave them agency. Inside the tank they were protected. They could move forward without being cut down. They could fight back effectively. The psychological transformation from helpless victim to empowered warrior was profound. Lieutenant Jacques Bossu, who commanded an FT section at Soissons and survived the war, wrote in his memoir, "For 3 years I was a target. The enemy shot at me and I could only hide. In the Renault, I became a soldier again. I could advance, fight, achieve objectives. The tank didn't make me invulnerable, but it made me effective. That mattered more than I can express. We weren't marching into machine gun fire anymore. We were bringing machine gun fire to the enemy. The psychological shift was total." The legacy of the Renault FT is ultimately about problem solving. Louis Renault identified a military problem, the stalemate of trench warfare. He analysed why existing solutions failed. Heavy tanks were too slow, too unreliable, too tactically inflexible. He designed a solution based on engineering principles: maximize power-to-weight ratio, optimize crew efficiency, ensure mechanical reliability, enable mass production. He tested his solution and refined it based on results. The outcome was a weapon system that solved the problem completely and established principles applicable far beyond its immediate context. This approach, using engineering methodology to solve military problems, became characteristic of 20th century warfare. The tank, the aircraft, the submarine, the guided missile all represented engineering solutions to tactical challenges. The FT was among the first and most successful examples of this approach. Renault wasn't a soldier. He was an engineer who applied systematic design principles to military requirements. His success validated the approach and encouraged its replication. Today, few people recognize the Renault FT. It lacks the iconic status of the Tiger tank or the romantic appeal of World War I aircraft. It's small, unglamorous, obsolete, but its influence is everywhere. Every tank on every battlefield, every military that employs armoured forces, every doctrine of mobile warfare, all trace back to a design created by a French industrialist in 1916 and proven in combat in 1918. The FT didn't just change armoured warfare, it created armoured warfare. Everything that came after was evolution of Renault's revolution. On July 18, 1918, Captain Duffieux watched 225 small tanks emerge from the morning mist and break through German lines that had been impregnable for 4 years. He didn't know he was watching the future of warfare, but he was, and that future, born at Soissons, still shapes battlefields today.